This is the first video in a series that shows how to make D3 installation on Linux easier by bypassing D3 Setup's configuration menu. In this video, we'll cover what Pic0 parameters are available for configuration in D3 Setup. Videos that follow this one will cover the Pic0 disk statement in particular, how to set up disk partitions for D3, and how to manually load D3 dependencies. D3 Setup was originally written, pretty much in its current form, back in around 2000 using a dialog-based tool for the GUI. It was pretty slick back in the day, but it's now rather clunky compared to today's more modern interfaces. Aside from the interface being old, D3 Setup has other issues. Two areas of note are memory and recognition of available disk partitions for D3's virtual disk. Back when D3 Setup was first written, machines had a lot less memory than they do now. You'd often see 100-user D3 systems running on Unix boxes with 500 megabytes of memory, or less. D3 Setup was trained to take 90% of the machine's available memory by default. That seemed like a good idea at the time, but since then we've learned that memory-starving Unix is a really bad idea. Letting D3 have 50% of the machine's memory is a much better solution for low memory systems. D3 Setup was never changed to reflect that point of view. As far as virtual disk for D3, D3 Setup has had a hard time keeping up with disk partitions in Unix, raw partitions, logical volumes, whatever. Often when attempting to add D3 virtual disk, D3 Setup either cannot find the partition or volume or cannot read the size correctly. The easiest solution is to create your own Pic0 file in userlibpic and use your editor of choice to set the configuration parameters yourself. Then when you run D3 Setup, simply choose option 1 to install D3 with current settings, which lets D3 Setup read your parameters from your custom-built Pic0 file and install accordingly. Before we do that, please read the D3 Setup section of the D3 Unix installation guides. There's one for Linux and one for AIX. The image shows the links. In both guides, check the Installing D3 topic and D3 Installation Options subtopic. There's also a really good section of the D3 reference manual devoted to the Pic0 file. That link is also shown in the image. Check out the Unix topic, the Unix file subtopic. Find the Pic0 file subtopic under that. Again, if you haven't read these before, please do so now before proceeding. Now let's look at the D3 installation options and how they are represented in the Pic0 file. The image shows the options as presented in D3 Setup's option 2. Now let's look at that same D3 Setup configuration parameter dialog alongside a sample Pic0 file and equate the parameters in the Pic0 file to the options in D3 Setup's configuration parameter dialog. Note that not all options in the Pic0 file are configurable in D3 Setup. A full explanation of every Pic0 file option is a discussion for another time. Within the scope of getting D3 Setup to run smoothly, we'll strip this down to the essentials, or at least the ones that are a good idea to have present in Pic0 when you install with current settings. For the purposes of this discussion, the most important statement is the disk statement. There's a lot to this one in terms of actual partition and/or logical volume setup in Unix itself, so this statement will be covered in detail in the next video in the series. The first statement in the list is the core statement, shown here as core 419430410. It contains the amount of memory to allocate to D3's shared memory pool and the machine key used to identify this virtual machine instance. As far as the machine key, leave it at 10 unless this is a virtual machine instance other than Pic0 on a machine hosting several D3 VMEs, in which case make it 20 or something else. Barring factors that would suggest you do otherwise, make this half of the machine's physical memory. In the above example, 4 gigabytes of the 8 gigabytes on the machine are being allocated to D3. The number you see is the product of this equation. 4 times 1024 times 1024 equals 4194304. Note that in a multiple VME environment, you'll need to make memory compromises, making sure that the sum of all memory allocated to running VMEs does not exceed the machine's physical RAM or leave so little RAM that Unix is memory starved. The next two statements are NPIBS and NPHTS, shown here as NPIBS 128 and NPHTS 128. These are the number of standard Pibs and Phantom Pibs. Defaults are 16 and 10 respectively, which is way too small for most systems. Remember, the number of Pibs must include all your logged on users as well as any printers you have defined. Making that number bigger than it needs to be won't really hurt anything and makes it easier to add user licenses or printers without doing a file load. As to the number of Phantoms, the minimum number of Phantoms licensed on a system is 12, so the default of 10 doesn't make a lot of sense. Check the D3 system ID, see how many Phantoms are licensed, and make this number at least 4 more than that so that there is room for the scheduler and all possible Phantoms. And as mentioned before, leave a little room for adding licenses to D3. The basic statement, shown here as basic 0, relates to Flash Basic Object Shared Memory. It's where a program can be loaded and made available to all users running that program so that each user doesn't have to load its own copy into memory. This used to be a good idea when machines didn't have gigabytes or terabytes of memory, but we really almost never need this anymore, so set it to 0. The flushers statement, shown here as flushers 8, allows you to define multiple flushers. Back when you could not have any more than like 4 gigabytes of memory assigned to D3, one flusher was plenty. Now that you can give D3 large amounts of memory, this setting will allow you to define multiple flushers to share the workload. Recommend one flusher for 8 gigabytes of memory in your core statement, with the caveat that you have fewer flushers than the machine has CPU cores. The last two examples are of the tape statement, shown here as D3 tapes, tape 1 and tape 2. This gives you a place to put your file save and other tapes. The first example is a compressed pseudofloppy with the 2 million indicating 2 gigabytes of D3 data in each volume, and the P indicating the type, which is compressed. The second is a standard pseudofloppy with the F after the 500 indicating standard density. The volume size of 500 prevents splitting the files into volumes, and the standard density makes this kind of tape readable by D3 Windows systems. It's a good idea to add at least one extra tape device. This extra tape device is just a scratch device that can be used for anything that comes up. Because we cannot create a Unix tape device on the fly and must use change device command to point to an existing device to a different device than the one configured in the PIC0, this extra tape device gives you one to use without changing another device that you use regularly. In the next video, we'll cover the PIC0 disk statement in greater depth. If you have any questions about any of the content we've covered so far, please contact Rocket D3 Support.